So greetings to everyone. I'm Victor Asachi from Yalantis, where we're reshaping the world of IoT software engineering. We craft custom software solutions that help companies across a diversity of domains discover new revenue streams, drive business success, and increase operational efficiency. And during our live stream today, our expert speakers will cover the topic of IoT software evolution, evolving products, boosting revenue, and reducing operational costs. By the way, if you have any questions on the topics of our presenters today, feel free to actively participate in the session and ask your question in the chat section. Our speakers will both have the Q&A sessions at the end of their reports, and you will be able to get your questions covered. And I suggest that we start with our first speaker, Maksym Moskvychev, who has over 15 years of engineering experience. He's currently leading the architecture and consulting unit at Yalantis, and he is keen on implementing the most effective IT infrastructure processes and architecture processes by applying architecture design methodologies. Maksym will tell you what business value technical assessment brings to a legacy system, best practices for architecture assessment, and processes and structure in conducting architecture assessments. So Max, please take the floor.
Thanks for introduction. So as Victor introduced it today, we will talk about technical assessment or architecture assessment, and we will have some overview in the beginning about what is architecture assessment, why it's needed in general, for what kind of businesses it's needed, for what kind of problems it's needed, and what are the business markers to understand when your business needs technical assessment. Then we will also discuss actually how we perform assessments, what are the processes, what tasks are done actually during this work. And in the end, we will talk about some deliverables, or what business achieves in the end of the technical assessments, which artifacts, etc., and how those artifacts can be used further. So starting from overview. So why in general we're talking about technical assessment? So technical assessment, we can rephrase, it's about understanding of your technology. By technology, here it's meant that it is a development, is existing software systems, and technical assessment covers points like effectiveness and efficiency of development, efficiency of processes, and in general, any other factors that can affect efficiency and effectiveness of your development. So in other words, software technology assessment is comprehensive evaluation that provides some valuable insights of health and performance of your software department, of your software development. And also, because we do technology assessments for business clients, we represent results of technology assessment in a format understandable for non-technical stakeholders, so that everyone in the company is aligned. Next section, let's discuss what are the markers for the business when they need an assessment. So there are some markers on the screen. We will discuss them and maybe even a bit more. So the first marker I'd like to discuss, it's market when market became more competitive. So when competition is growing, then for business it's important to keep up with competition and grow their competitive advantage. And one of the competitive advantage can be on the technology side, so that because of better technology they get more clients, more customers, and win this competition. It's, for example, a good example this year with ChatGPT starting growing, starting more popular, and in some business areas, because of some companies became using ChatGPT, they became more competitive. And for other companies, it's just an example, but yeah, for this example, other companies to get not to lose competition, they also need to do the same or even something better. Then another marker, it's time to market delays or tight deadlines. Sometimes we have a tight deadline to deliver something for release to production or to prepare for some big event for customers which was advertised, and we cannot miss those deadlines. And in this case, technology assessment really helps to be sure that we will do it in time, because part of the technical assessment is also to understand all the risks that we have, make mitigation plan of the risks, and actually mitigate the risk as much as possible. Then another marker is operational inefficiency. It can be in costs of hosting, for example, or in costs of development. We see that probably it takes too much efforts or too much money to cover all the hosting costs or development costs, and we believe that, or clients believe, business representatives believe that it can be minimized. And yes, technical assessment can give answer to this question. So after assessment, we can understand what exactly can be reduced, which costs can be reduced. Then another thing, it's a strategic alignment. In some big companies, when technology is not the primary focus, there could be misalignment that some stakeholders think that something is achievable with technology, but that is actually not. And technology assessment can resolve feasibility questions. So what is feasible to achieve this technology and how much it will cost? And after this information, business stakeholders can align finally, do they want this project or not? Another marker, can be vendor lock-in. And it also a bit relates to competitive advantage. For example, if you're locked with some vendor and basically you kind of resale services from that vendor, you cannot be better than that vendor. And if you want to win competitive advantage, then sometimes you need to be in some ways better than vendor from who you buy services. And understanding those areas and preparing the plan how to achieve those competitive advantage can be also solved with technical assessment. And the last point, but pretty popular nowadays, it's preparation for company mergers or acquisitions. So to be prepared for new buyer of the company or to be prepared for the merge, it makes sense to do technical assessment to make sure that technology department is working good, it's healthy, it's effective, it's efficient. And in the end, the company became more valuable when the technical department is good. If you have any questions, you can leave them in chat, and then I will answer all of them. But we will go further. So next slide. What are business benefits of having technical assessment? So the one of the biggest benefits, it's minimize uncertainty. So on this diagram on the right, it's uncertainty in estimate. And it says then, for example, when there is some project idea, and it's in many cases, when it's big project, it's very hard to give the exact estimate how much time this project will take. And also this chart illustrates that after the discovery phase, it's terminology that describes that we will dive deep into the request and we will understand what exactly can be achieved and how. So technology assessment is one of the forms of the discovery. So after technology assessment, we reduce uncertainty significantly, and in many cases after technology assessment, we can be much more sure about our estimates, and variability of estimate become much less. So, and actually the most of the projects, especially the complex projects, make sense to start them from the discovery or from the technical assessment. Technical assessment, it's needed mostly when it's existing business with a lot of services, with a lot of technology already in place. So we need first to understand what is baseline architecture, what is happening currently, and then think about future. And yeah, discovery, it's more applicable for new projects when client has nothing and they want to do it from scratch. But the idea is the same. Another business benefits described on this slide. So number one is identifying technical debt. What is technical debt? It actually can affect the cost of the project significantly. For example, to the technical debt, we can add some proof of concept, for example, some and some other activities that needs to be done beforehand. As an example, there is some service in cloud provider, and the DevOps team wants to implement this service, but they don't have experience with this service, and we plan that in the project we will use the service. So the proof of concept that needs to be done in this case is to that the DevOps team try this cloud service in order to understand how it works, whether it fits our needs or not. Because if don't do it beforehand, then when development teams come to use it and the DevOps team also will try to implement the service, it could be that it will not work out and we need to find another solution. But at that moment, developers already wasted some efforts, wasted some time on wrong implementation, and it's not good. So what is good is to have some technical roadmap with technical debt, plan those activities beforehand, and this is like one of the way of risk mitigation. Yeah, number 3, risk mitigation. It's about the same thing but from another perspective. So after understanding the risks of the solution, you can plan mitigation plan for every of the risks, and for some of the risk mitigation plan can proof of concept. For other risks mitigation plan could be to change the solution to avoid those risks, etc. About cost efficiency, we spoke already, so it's about that technical assessment can also evaluate costs for hosting and plan the hosting in a way that it will be more cost efficient. Technical assessment can also evaluate the choice of third-party vendors which are used in the system to choose vendors which are more cost efficient. It's also about quality assurance, about some future-proof solutions to make sure that what we are developing now will bring us competitive advantage for a long period of time, etc. But yeah, benefits are not limited to these ones. There are much more benefits from technical assessment. It's just 6 examples. So let's talk about assessment goals. We separate that into product goals and technical goals. We separate that also because in most of the cases, technical assessment performed by a team of engineers, not by one engineer, and there are technical engineers like architects, developers, etc., and there are representatives of business. It can be business analysts, can be subject matter experts, etc. And so you will be able to read those items in the recording, but from the high-level perspective, the most important deliverable from product goals, it's define project scope and prioritization of project scope. From technical perspective, the most important is to build the target architecture solution, and also the common goal of product and technical, it's to build roadmap with budget and also with risks. So that in the end of the technical assessment, so we take into account all the business goals that our stakeholders want. We prepare that solution from technical perspectives, like which microservices to build, what infrastructure should be, what is technology choice, etc. We build solution from product perspective, so we build scope of the project, priorities, define functionality, high-level requirements, and in the end we combine all that into roadmap and into budget calculation, like how much would it take to implement everything the client wants. Now we will talk about some details, like how exactly we perform technology assessments. So there is a 3-phase approach, and assessment is one of those 3 phases. So assessment is phase number 1, when we understand baseline architecture, or as this situation, we define based on some architecture drivers target situation or to be a situation, and then we also build roadmap, project scope, etc. Then there is implementation, when developers follow the plans that we prepare during technical assessment and implement the functionality. Also, there could be some governments, implementation governments, things in this phase in order to make sure that architecture is implemented as it was planned, that scope was implemented as it was planned. And there is then next enhancement stage when business stakeholders analyze what we have achieved and plan the future iteration. Future iteration can again start with assessment in case it's complex, in case it's more simple enhancements, they just go directly to the implementation. And now about assessment flows or about the first phase. So from which steps it consists. And so the first step is to define business goals and requirements. So there could be different requirements, and to structure them, we separate them into business goals. So it's like high level what business wants to achieve after the assessment and after the implementation of what can be planned during the assessment. For example, business has some goals to deliver some functionality, I don't know, in half a year, and they perform technical assessment. So what they want to achieve in half a year, it is the business goal. Also, that could be some non-functional requirements, quality attributes. There are some constraints. Typically, clients has constraints in budget or constraints in time. They could be also architecture concerns, like some technical things that needs to be taken into account, and without taking that into account, it will not be possible to achieve the functionality, etc. So all that are these architecture drivers, and those are collected on step 1. Then on step 2, we analyze the current situation. So we draw baseline architecture. Baseline architecture, it's about what client has at the moment, and we draw that on multiple levels. It's business architecture, like how high-level services are connected to each other. Then it's data architecture, like what we store in database, is it encrypted or not, and how this data is shared between services. And then it's about technology choices, like what programming languages is used, frameworks, etc. And the last level is infrastructure, like how exactly is deployed in cloud provider on-premise, what is network diagram, what is service diagram, etc. Next step number 3, it's to define quality attributes and quality attributes scenarios. So quality attributes, it's something that can be made out of non-functional requirements, and quality attributes, it's actually a way how to evaluate quality of the solution that we developed. For example, one of the most common example of quality attributes, it's performance. Performance of backend, for example. And we can define quality attribute scenario is that our API performance should be, I don't know, 200 milliseconds when there are 100 requests per second to our server, and when our database, I don't know, 10 gigabytes. And that should happen during 1 hour. And if during 1 hour we have 1 request per second, then an average response time should be 200 milliseconds. So those is quality attribute scenario, and it defines how to measure the performance in a way that we agree for the project. And this quality attribute actually evaluates the quality of the solution, because in case our API responds in 200 milliseconds or less in this scenario, then quality of the solution is good. In case performance of API is less, for example, 500 milliseconds or 1 second, then quality is less than we expected. And the same way can be achieved with other quality attributes. Then step number 4 is analysis of codebase, of infrastructure, of everything that has client, in order to build target architecture and recommendation based on what client has, in order to reduce efforts. For example, in case client has some already parts of the code, it's better to reuse them in case it's possible. And then step number 5, It's actually to document our target architecture, document what recommendations we give to client, what he should do. And number 6 is to present assessment results, present recommendations, present our roadmap. And then, yeah, it's up to client to implement something from the roadmap, not to implement, implement with which provider, with internal developers, or with us, or with other company. Let's go further. So this is example of the roadmap for the technical assessment. So most of the technical assessments that we did were either 2 or 3 weeks. So for more complex projects, it's 3 weeks. For more simple projects, it's 2 weeks. And this is how it could be. So on the left, you see different roles that are engaged during the assessment. In the top, there are weeks and days of the week. So what we have from the roles, we have BA, it's business analyst, and then we have technical team. Technical team is architect and experts. It can be developers, DevOps, etc. So in the end, we define business goals and do requirements collection. And then business analyst is doing requirements refinement, preparing user story map, and other product documentation. During this time, architect together with experts analyzing current architecture, then architect define quality attributes, and then architect together with experts are defining target architecture, like how it should be when we finish the project. They write down recommendations, write down architecture decisions, building blocks, etc. And yeah, in the end, we present the report to the client. And interaction with client is actually pretty frequent. It's not represented on this slide, but in most cases, maybe in the first week, interaction with client is needed every day. From week 2, maybe every second, every third day, we need interaction with clients because there are a lot of questions which needs to be resolved, and without that, assessment will be delayed. Okay, let's go further. This is about the first step, how we define like requirements, technical requirements out of business objectives. So this is a thing which I explained briefly already. So now I will explain one more time. So there are different levels of drivers, of architecture drivers for the assessment. So it all starts from business goal, which comes from the client. It can come from indirect way or not indirect way. In case it doesn't come from client in direct way, then it's our task to define it, to discuss with the client and write down the exact business goals. Then out of these business goals, there are also some architecture drivers or assessment drivers. And from what it contains, there are constraints. So constraints can be limitation of clients. For example, I want to achieve this in 2 months or in 6 months. Then it could be constraints regarding the budget, some limitations that client wants to spend for the solution, but he don't have money or don't want to spend more money for the solution. It can be quality attributes and NFRs, which we discussed already. It can be features and use cases. So use cases, it's more like high-level thing, and features, it's more like detailed explanation of functionality. And on the right, there are quality attribute scenarios. It's about how to validate quality attributes and architecture concerns. So in the end, taking into account all the things above, we design the system. And here is example of architecture concerns from the previous slide. So what can be in architecture concerns? So there are some general things and specific for the project. So in general things, design and system context. System context is terminology from C4 model. So system context, it's about like what third-party services should be used in the solution, whether to implement most functionality with software development or to use some existing SaaS, open source solutions, etc. Selecting reference architecture, pick up some programming languages, etc. The specific concerns are more defined by the project itself. One of the popular specific concerns is cross-cutting concerns. So the cross-cutting concerns it usually included things like logging, how we work with log files, it's alerting, monitoring, some observability, ability to do customer support, etc. So it's defined basically from previous slide, it was architecture drivers, and architecture drivers define which concerns with which architecture concerns should we have. And now let's talk about assessment deliverables. So there are deliverables by project manager, business analyst, solutions architect, and domain experts. So what project manager is doing during the assessment? So it's basically communication plan, collaboration plan with client. It's risk register and also building the roadmap when assessment is being finished. And then for business analyst, deliverables are evaluation of business context, checks whether it's feasible from legal perspective, whether it's feasible from regulatory perspective, whether we need to have some certification in order to implement this project or this part of the project. Then it's about some solution assumptions, dependencies, constraints, etc. And yeah, that's it. And then regarding the solution architect, non-functional requirements, it's actually shared responsibility between solutions architect and business analyst. It's defining technology stack, it's defining architecture, target architecture, baseline architecture, and making trade-off and risk analysis of his solution, etc. And then also we have domain experts who added to the assessment team with some exact purpose. For example, in case we need to analyze some code base and it's a pretty big amount of work, then we engage some engineers who can analyze it. Or for example, in case, I don't know, it's maybe some IT system which needs some expertise of how exactly, by which protocols some devices can be connected, then it can be a domain expert which has experience working on project with those devices. They know, and he knows capability of those devices, and he can design system with those devices. It's a high-level overview of the deliverables from the assessment. So one is assessment document. So assessment document include things like architecture drivers, so all that things like business goals, constraints, concerns, quality attributes that we discussed previously. So it all will be defined there. Also in assessment document, it will be architecture diagrams of baseline architecture and also on target architecture and on multiple levels. It's business level, data level, infrastructure level. So it's 6 diagrams in total. Also, it's technology choice, also risks and trade-off analysis with risk register and mitigation plan for the risks, and also roadmap and roadmap is separate thing. Then another next deliverable is user story map. It's prepared by business analyst, and user story map gives a good overview of functionality and the scope of work. User story map is also split by applications, and it's a way how like the most effectively and efficiently to discuss the scope. So instead of discussing scope on individual tickets, better to see how it looks like on user story map, and then it's much more efficient. Business requirements already discussed it, and then roadmap. It's like what parts of the project, what parts of the scope will be implemented after what. Also, roadmap includes the specialists, like which engineers we need to have, how many engineers, which engineers needs to be added on what day of the project or on which month, etc. And also the budget, it's also part of the roadmap. And yeah, in the end, to wrap up today's meeting, so in which cases so in which cases we need assessment? We need assessment when there are certain business markers, which we discussed, when there are some markers that development is not effective, not efficient, that we need some improvements, or we need to get competitive advantage, etc. Then the approach is that we define baseline architecture, we define target architecture, we take into account all architecture drivers, we take into account risk and trade-off analysis, we take into account the scope and user story map, and in the end we build roadmap. And some highlights, some numbers. So assessment usually takes 2 or 3 weeks. There are typically 4 engineers engaged into assessment, and more than 10 artifacts is presented in the end as deliverable to the client. That's it. Thank you.
All right.
Let's see what questions do you have, and let me answer them.
Yeah. Yes. Let me also please jump into the conversation. Thank you so much, Max, for the presentation and the detailed dive into the architecture assessment. We actually have some questions. Let me just read them out to you. The first question is, people are asking for statistics. Based on the client requests, how often do you have to rebuild a legacy system into a new architecture from scratch? That would be the first one.
Build legacy system to new architecture from scratch. Well, in most cases, I would say in 100% cases, it's combination. So established company always have some parts of the business, some parts of the software, which is good enough to keep it. And so we try to keep as much as possible, and then some parts, some services we replace with new ones, also because of new business requirements. There are some small companies who don't have their software products at all. For example, they use combination of SaaS services plus a bit of Excel. So it's like very manual processes. For that companies, yeah, we built some systems from scratch. But for other, in case they have some in-house development software, yeah, we always keep it.
I see. Thank you. There are some more questions. The next one is, I guess, about the strategy of legacy systems. In the long run, which is more cost-taking, supporting a complex legacy architecture or rebuilding and maintaining a new one?
Yeah, in long run, of course, not only in long run, but in general, better to review architecture from time to time with architecture assessments, or maybe with some more simple ways, and to try always to go to updated target architecture, because something that was designed, I don't know, 2 or 5 years ago, they don't meet current market needs. So something is changed, some business goals changed, some situation on the market changed, some new competitors arrived. And it's better to review architecture either once per year, and for some more effective companies to review architecture 4 times a year, so every quarter. And based on the updates, you then perform new development to build new software in order to achieve the new updated architecture. Don't try to follow some architecture that was defined 2 or 5 years ago.
Thank you. And the very last question, I guess it's about the industries. which types of companies usually request the architecture assessment from your experience?
Yeah, from my experience, we had a few cases when the question is about business areas or about the reason why they request architecture assessment.
I guess it's more about the business areas. Yes, people are looking for more statistics and information about are there any patterns, for instance, can you say that some of the IoT manufacturers need to revise their architectures more often, or should there be some, say, supply chain management companies or some kind of manufacturers, plants that are requesting these architecture assessment processes more often than the others?
Yeah, thank you for the question. Actually, talking about the IoT, yeah, we had few architecture assessments this year, and from IoT domain, or some of them also from security and IoT, because after IoT devices and cheap IoT devices appeared on the market, there are a lot of ideas, so many people has ideas how to apply that, and it's unlimited amount of ideas, and they want to implement better approaches to do something more and more for their customers, for their clients. But it's not only limited to IoT. There are clients who ask for assessment from healthcare industry, from logistics, from fintech. Actually, it's a lot this year.
Thank you so much.
One more thing, it's very actually also popular to ask technical assessment companies or like divisions of companies who are working with data. It can be business intelligence, or it can be machine learning data. And for those companies, it's especially needed to do technical assessments, because nowadays technologies how to work with data, how to work with business intelligence are changing every year. So every year we get better and better approaches, cheaper and cheaper solutions. And in case companies continue to support some tools which they has chosen 5 years ago, they just waste money. They can have much simpler solution, much more cost effective, that needs much less developers to support it. And because of that, they come.
That's great. Thank you so much for these insights. I guess we can already get the idea of first of all, of the regular architecture assessment procedures that are actually necessary to most of the businesses once in a couple of years. And for some particular industries that are constantly working with data, with AI, with machine learning, these particular companies actually require it a bit more often. And of course, for those who are looking for cost optimization opportunities as well, right?
Yes.
All right, Max, thank you so much for your presentation. I'm sure there will be even more questions later on, but unfortunately we're pressed for time, and we need to move on to our next speaker. And just a little spoiler alert before we jump into the next announcement. I wanted to let the listeners know that if you are interested in the architecture assessment planning, you can actually request make a request on our website. And get an architecture assessment plan for free, so that you could just decide if you are actually in need for cost optimization, if you're actually looking for the opportunity to revise your current architecture and get more streamlined performance and stuff like this. You will be able to get this plan from our website page. I will actually send it to the chat. And I will also later send it to the email boxes of our listeners. And now let's move on. Well, surely enough, I will send it to our chat box later. But Max, thank you so much for your presentation. We're moving on to our next speaker, who also has an impressive record of accomplishments. Olexandra Zhyltsova is already here, and she's a senior business analyst that is specializing in IT projects. And a couple of facts about her are the fact that she's got more than 15 years in IT, Behind her back, besides business analysis, Alexandra worked in IT, product marketing and product management. And for the last 3.5 years, she's been working exclusively with the IoT projects in the IoT industry. And she has worked with IoT solutions of various sizes and various stages, from pre-sale stage startups to enterprise-grade IoT ecosystems. So without further ado, Alexandra, please take the stage.
Wow, that was really cool introduction. Thank you so much. Yeah, my name is Alexandra, that's true. And today I hope to share some experience, mostly some ideas with you as for how we are building and planning IoT software ecosystems. So a quick introduction of myself. Thank you, Victor, for quite an impressive introduction. Basically, you said everything, so I probably skipped this one. Just maybe a quick note that yes, for the last 3.5 already year, I work almost exclusively on IoT projects. They are very different. I used to work on pre-sales, and now I'm working like exclusively on the production teams. So it gave me several hints and notes and some ideas from different businesses and from different perspectives, how an ecosystem, typically starting from the hardware core, evolve into actually being an integral ecosystem, which includes several software solutions around an efficient hardware. So I really hope to share them with you today. And here is how I suggest to structure my presentation, not to take much time and to prepare you guys for what you might expect. So first of all, I wanted to make a kind of context capturing slide to say that from our experience in Yalantis, it's pretty common situation when an IoT vendor starts with the hardware/embedded firmware ecosystem, which is almost exclusively centered around devices. I wanted to take a note what this business looks like, where we basically get money from and where do we spend it on. And as the next step, to make a kind of contrast, to show how we can add more software, client-facing software to this solution ecosystem, to this mix, to open additional opportunities for generating new revenues, for generating more brand recognition, and maybe even cutting some costs. Again, not pretending to be an ultimate truth in here, but just to share some ideas from different businesses, how guys are evolving their ecosystem and what opportunities they found on the way. Working with different IoT projects inside Yalantis, I'm lucky enough to have at least one vendor who is, let's say, brave enough to share their name. We do not have such a strict NDA agreement with them, so I'm happy that I will be able to share some actual business case with you and illustrate all those ideas with some actual projects that we built together with one of our clients. And at the end, really hoped to do a kind of summary in terms of what are the risks, what are considerations that need to be basically examined by the product team, by all the stakeholders in the business when the decision to go further with expanding the ecosystem and bring in some software, this idea is taken. So let's proceed. We will start with this one slide that I promised. When we're talking about the ecosystem, which is almost exclusively centered around devices, what are the main drivers in here? It's very simplified, obviously, but still. Basically, we are selling devices, meaning that we spend some money to produce each unit and we get some money when we are selling each unit. This is a per unit business, and sometimes we do spend, we make some one-time investments to develop some custom device to adjust it maybe to some specific business case. And after that, again, produce it and sell it unit per unit. And the second direction, the second branch in this business are all different kinds of maintenance and service and support contracts. So we are maintaining our devices, we make some service around them. So we basically spend money on having the support team on board, in-house support team, and we are gaining this regular service fees from this type of work. Sometimes we also might have some projects of deploying big number of our devices on site with the client, and thus it will be like per project cost and per project revenue. Very simple slide. And to take the next step, if we are to add an additional software to our ecosystem to build a kind of extended value solution, value proposition for our client. So typically, as my personal experience shows, the first step that this type of vendors usually make is to add a kind of centralized management system that will help to bring the very idea of the product from the level of one device upper to a business case, meaning that the logical entity, the unit of management would be not a single device, but it will be some logical group of devices. It will be the actual business case. It usually means a kind of remote management system, which allows to see all those devices, to compose them in more complex logical entities and basically manage them. It can be for setting those devices up, for configuring them, for monitoring them, like a typical device management platform. It can be something related more to the data which those devices produce, like to aggregate this data, to pre-process this data, to process it, to build some decision-making solutions around it. So it's all about client-facing software, which considers devices as like multiple devices, groups of devices. This is a typical first step, but it's not an exclusive thing to add to the hardware software ecosystem. I will share more ideas later on. But if we consider the simple first step, we can see immediately two potential new revenue sources for the company. So the first is the software in itself can be monetized. So when we are talking about remote management, we most likely are talking about cloud solution. And cloud solutions allow us to build this very well scalable and working SaaS model. So this software might have different tiers of subscription. It does require some usually significant investment in the implementation stage. These are one-time investments. After that, the software works, it is introduced to the market, it scales pretty perfectly, usually around the globe, and brings regular revenue. Definitely, and it's important to understand the software solutions need regular support, as Max said previously. Not only architecture needs to be reviewed regularly, but also some customer issues need to be addressed. Some improvements need to be made based on how the market actually changes. So another obvious hope in here is that we hope that by introducing software, by basically introducing to the market an extended value, we will boost the device sales. So once we are basically bundling them together with some tools how to actually apply those devices to a specific business case, we hope to sell more. It goes as a bonus, so we will reuse the implementation, the software implementation cost, but we do hope to have this extra sales and thus increase the revenue. Besides these two very obvious factors, there are actually more opportunities. So I want to stress them out, again, not pretending to have some business ultimate truths, but still, based on our experience. The first opportunity is there are new partnerships that might be opened by introducing software layers, software components to this extended ecosystem. First of all, when we are selling not a set of singular devices, but also some management platforms, software platforms, actually turning these devices into some business case tools, we become more interesting for end-to-end IoT project consultants, because we are checking more check boxes in their needs list. And we are again delivering the whole business case, not just devices.
Moreover, if we are talking specifically about managing larger business cases, we are start to attract such an audience as managed service providers. Those guys are potentially managing multiple big deployments, and they are interested in some reliable solutions, well tested altogether. So this is a proprietary hardware, and here is a proprietary software, which is proven to work fine with this hardware. By investing a bit more, or maybe not a bit more, to be honest, into some complex features to meet the needs of this type of target audience. This is usually related. They are mostly concerned with the security. They are very sensitive to multi-tenancy of such solutions. They usually require some multi-level user management, user permission management systems. But if we decide to do so, MSPs can be a very interesting target audience because they mean larger amount of devices, right? And potentially these might be more interesting service and support agreements with them. Besides MSPs being like bulk customers, when we're talking about software, it's much easier to integrate software to software than to integrate hardware to third-party software. It means that we can take our extended ecosystem now and integrate it with some other IoT market players, if we are talking specifically about IoT, to create a kind of synergy. When you have software, when you have those ready APIs, it's much easier to integrate these things and create even bigger value proposition. So to the next ideas in terms of opportunities. When we are developing software around hardware, those client software solutions used to have lots of self-service features. We do want to scale the solution to attract more and more customers without proportionally scaling the support team, our accounting, our customer support engineers, our technical support engineers. We do want to serve more customers with basically the same team on board. How we make it happen? We introduce a lot of self-service features to the software, starting with some obvious self-service onboardings like registrations, providing basic billing details, business details, deployment details, and so on. We can also inbuild several self-service diagnostic troubleshooting tools, even an automated frequently asked question checklist can cut some percentage of tech support issues and make those customers manage them themselves. Another thing is that when we're talking, for example, specifically about remote management software, we need to understand that we are providing remote troubleshooting and monitoring and management tools not only to our customers, but also to our own indoor tech team. So again, some percentage of issues of support requests now can be managed remotely without going on site to the client, which definitely saves some cost. Another interesting idea here, and actually we'll be explaining it more in an example that I have, is that having this, let's say, software wrap around the hardware, around our devices, we now can take the further step and include even more customer journey stages into what is covered by our solution. So we can integrate with the internal manufacturing, device testing, customer relationship management subsystems, and ensure that once device is manufactured, for example, it can be discoverable. Once it's sold, it is visible to the customer. Lots of things can be automated, basically, and we can automate provisioning. We can automate pre-configuration of the devices. We can automate adding those devices to our customer accounts. So it can create, after all, smoother customer experience. And again, it allows us to save some operational costs on potentially on those actions that were potentially manual before. Let's go to the next opportunities I brought here today. Another type of audience that we might have is the R&D community out there. When we are producing devices, when we are producing not only devices, but also some customizable devices, devices that might be used in different business cases, or it's not even the end devices, but maybe some components that can be reconfigured, that can be composed together, we might be useful for very different market verticals and very different business cases again. And even if the vendor, the IoT vendor, is not interested at this very moment in investing in a specific business case, I don't know, maybe it's just a very narrow segment of the market, there might be some third-party enthusiastic, hopefully, R&D team which is ready to do so, because it's maybe relates to their business, maybe relates to their, I don't know, hobby or something like this. And if we provide them with more flexibility, with some R&D tools, with some open frameworks, if we invest in designing flexible architectures that might allow customization, that might allow having some custom code, custom module inside, we potentially create a community which might produce even more business cases for us. Besides that, it's always good for the brand recognition, especially as we have so many enthusiastic R&D guys in education market and education sector. So it's cool. It also creates a loyal base of beta testers for all our experiments, for new projects, for new features. If we provide those guys with no access to this type of things, we might gather statistics, we might gather early feedback, which is always cool. And having, again, this software layer around everything, it allows us to capture those statistics automatically. And which is always great, again, for as some rationale for any improvements and changes. So describe several set of ideas, several set of potential directions of growth, of evolution for this ecosystem. Now wanted to illustrate it with one and only case that I'm allowed to share with you, which is always nice. So one of beloved customers of Yalantis is the Rock Wireless company. They are the Shenzhen-based IoT vendor. They're very universal, so they produce one branch of their business. They produce IoT networking devices, everything starting from gateways and down to different antennas, some signal monitors and things like that. And they have a very strong R&D branch for end devices. So they produce different sensors for a very wide set of verticals, starting from smart agriculture and down to smart healthcare, which engages IoT devices. They also produce a set of core modules, communication modules, smart hubs that basically allow to build custom IoT devices on top of some ready components, proprietary components by this company. This company is working with us for more than 3 years already. And I'm proud to say that it's not one project, it's actually the whole program already. And lots of projects are in production right now. So we're proud to say that this is a support stage for this account. So let's take a look what they have. I will start representing this case from the IoT networking branch. So everything started with us, and for this vendor, everything started with a set of smart IoT networking devices, the gateways. They were managed by proprietary firmware, and the customer, this company, brought Yalantis to implement the actual idea of the big cloud IoT network administration platform that would allow to build IoT networks on top of this proprietary networking equipments of virtually any complexity, of various sizes, allowing smart onboarding, smooth replacement of hardware if it's not working, smooth reconfiguration of the devices, rebalancing the network, troubleshooting the network, everything, virtually everything, which relates to setting up IoT network and making it work day by day was and is covered by this cloud management software. It is in production right now. It has very different subscription tiers, starting with the free one to meet the smallest enthusiast-like deployments, and up to enterprise 1,000 plus tiers, which are basically managing networks of several thousands of nodes. And nodes, I mean gateways, not end devices, gateways. So it was a success. And it was the very big first step to extend the hardware ecosystem with the software component. What we did next, we took a look at the customer journey of those companies, MSPs, enterprises, and smaller businesses who are building their IoT networks. And we took a look at how the operational tasks are organized within the Wireless company. What we did, we integrated with their MES and ERP systems to make sure that once the device is manufactured and tested, it is automatically pre-provisioned to our basically our cloud infrastructure. It made this device discoverable for remote management at once. We also integrated with the warehousing and order shipment processes to make sure that once a specific hardware piece is assigned and shipped to a customer, it's automatically added to the customer's account. Thus, that basically meant that once a device is shipped, it will take several weeks to be actually on site with the client, but it already can be pre-configured, so those network administrators can already start to prepare configuration, know all the technical characteristics and types and models of what they bought. Once the actual hardware is delivered, and it can be delivered not to the central office for configuration, but already on site, once these devices are connected, everything gets synchronized automatically, and basically everybody has the network already set up. So with this even more extended software hardware ecosystem, we covered some previously not covered customer journey steps, making a smoother experience for the end customers. Another thing that I wanted to share, this is just an idea. So Wireless board decided that this is probably not the first priority for their investments right now, but still wanted to share the direction of our thought, how the ideation worked. We looked even further to the customer journey and decided to cover that stage of planning the future IoT network. A piece of a context here, one of the key technologies that Wireless work with is the LoRaWAN technology, the LoRaWAN protocols. They heavily rely on radio frequency bands to transfer data. It is very cool and stable protocols for standards for multiple business cases, but it's still pretty much impacted with the specifics of the landscape, the density of building in that area. So what we decided to do is to suggest a software for those guys who are just planning to set up an IoT network in some specific area, to integrate with the vendors who provide geographical and signal coverage data, and actually help those guys to decide how many devices do they need to buy, where to locate those devices, and what are the optimal configuration for them. Definitely integrating it at the end with our IoT network management platform to capture all those configuration, to create pre-templates for configuration, and took it from there further to the customer journey. Still an idea though. So another idea to share, I wanted to jump to the second branch of the Rec Wireless business. This is a branch for end devices. Again, to say Rec Wireless produces both the end devices, let's say end devices, those are ready sensors for specific usage scenarios. And they also produce multiple components and modules that allow to put together a custom IoT end device serving some specific need. They also have components which are potentially compatible with third-party solutions and other guys' solutions. What we suggested for this branch, we built a family of desktop solutions around those end devices, primarily targeting the R&D teams and prototyping teams, allowing them to configure those devices, to build a custom code around those devices, to test those devices, to have this quick prototyping tools like templates, libraries, like firmware customization, and like library of official firmware, the library of custom firmware, the results of those experiments, and so on. We also delivered a software solution for in-house Rec Wireless team, helping them to make those modules and sensors, new components available to the development community as soon as possible by basically automating the way they create those development interfaces. Lots of tell about there, we'll still proceed. Another addition to the software ecosystem around this smart and very versatile end devices. Rec Wireless produces a cloud tool for 3D industrial design for the custom end devices. So basically it is a web-based tool which has the library of all the components Rec Wireless produces, and it allows in a drag and drop mode to compose a custom device with automatic checking of compatibility, of technical limitations, of whether the power is enough, the connectivity is done. It allows to measure the potential case and potential size of such a device, and so on. It is definitely integrated with the internal processes. So after a customer, after a simple registration onboarding process created this type of thing, they can send a pre-order form to a wireless internal system to basically ask for a proposal for manufacturing the test batch of those custom devices. And another idea was an idea there, idea here, also in the backlog, also not the first priority, but still for the general picture, wanted to share it as well. As you probably noticed, we went by the way of integrating things, not created those sporadic, very distributed areas of software, but making it a really integral solution, an integral ecosystem. So we are all about integrating those parts together. So the next idea for integration was between this IoT network management and IoT and device management branch to make it even easier to actually build working IoT deployments, taking care about the network, taking care about end device health and visibility inside. This is actually the last slide that I have. I know that in this type of presentations, last slides are usually some very optimistic vision of the perfect future. I decided not to do that. We'll use this slide for kind of disclaimers. So what my teams personally noticed during those years of helping IoT vendors to extend their ecosystem and jump from being an exclusively hardware vendor into software/hardware vendors is that there are some pretty obvious things that at the end are not so obvious for those guys. So when the decision is made to build software around hardware, what those teams face? First of all, they discover that indeed, to manage this type of multi-platform, cross-platform solutions, some specific project and product management skills are required. to make sure that nobody is blocking anybody else, that the delivery schedules of different components and new versions for firmware, for example, and cloud integration clients, they are synchronized in terms of delivery schedules, and they are synchronized in terms of vision, and all those new stakeholders that probably were never put at the same table before, everybody is heard. Those guys who are responsible for the client-facing solutions, those guys who are responsible for manufacturing of hardware, the marketing team, the sales team, they all come together and they start to discuss not only devices, but actual business cases. And it immediately means that more and more stakeholders need to be brought together. And it does require specific skills to manage this type of teams and this type of groups of stakeholders. The related idea is that it will inevitably bring new roles to this team, starting from some obvious roles like UI UX designer that probably was not there before, and some DevOps guys, like cloud security engineers guys, but also some intermediate facilitators who actually allow to capture all those different aspects of needs, of requirements, of limitations, of technical specifics together and help to make decisions on the edges of those teams. It might be architect, it might be tech leads of different directions, it might be business analyst, as I am, allowing those guys to actually come together. Then I will jump to the last one first, which might be a bit strange, but still. Those teams where different tech guys from very different tech background come together and they need to integrate between each other. It inevitably brings this team to a storming period. That's something that I observed multiple times in multiple teams, because when the hardware guys, they were doing pretty well before that, they were doing things as they like to do them. And suddenly some web development guys come and say that something needs to be reworked, something needs to be done in a different way to help those things integrate. These teams will come into a period of storming when they need to decide both some communicational flows, some technical flows, how they will actually work together and integrate. So the hardware team would probably need to come to terms with the idea that they would need to adopt things that they were doing before this moment. And the cloud guys will need to understand that sometimes hardware behaves just like the way it behaves and nothing can be done with that, and they need to find a workaround. And maybe the last idea here is that like with any type of investment, investing in the big software projects brings risks. Those are marketing risks, those are risks of wrong assumptions, like wrong assessment of the priorities from the customer perspective. It does need lots of understanding of how those business cases actually working on site. What is important for the customer, what they can live with, what they cannot live without, and so on. And whatever agile the team is, and whatever cool the stakeholder management skills of this team is, still, yes, in the core of agile, in the heart of agile, is the idea that as soon as possible, we need to provide some palpable, feasible, like something real to show to the stakeholders and preferably to some focus group to confirm that we are doing the right thing, that the final vision is correct, that the market will respond well to this something. But we need to understand when we are talking about integration with the hardware, this transmission period, this migration period will take some time. It will still take considerable investment to have something palpable to show to the target group. And when vendor decides to go with the software addition to the ecosystem, they need to understand that it will take time and investment. So it takes courage to do this type of thing. Well, on this mixed note, I will finish my presentation. Thank you. Are there any questions maybe to me?
Yeah, well, first of all, thank you so much for the presentation. I wouldn't call that not an optimistic slide, though. It sounded more like an educative slide. So thank you so much for sharing your professional experience in crafting IoT solutions. Yeah, we have actually got two questions because one of them has already been covered in this particular slide at the end. So the first sounds like this. How can software solutions for proprietary IoT hardware be designed for maximum customization and flexibility? Well, I guess preparing for the future scalability and customization. So is there any kind of a trick, silver bullet, or maybe a set of practices so that you could craft a really customizable and flexible software solution for proprietary software?
Cool question, quite an elaborate question. Thank you, whoever asked it. I would say that this question not that much to me, but maybe to Max most. But if I got the question right, so what I observed with the projects of my clients, the first step is designing a flexible architecture, the one that supports actually some custom module and custom code inside. It will require developing kind of universal interfaces, set of commands that this development community can follow to deliver the customizable parts. This is if we are talking about customization right on the embedded level and bringing it further to the development community with the software tools. If we are talking about the software being customizable, it's all about like a general universal tools for customization for software. So it will very heavily depend on the type of software and the type of project at hand. Basically, yeah, it's very hard to do kind of universal, to make a kind of universal suggestion. See on the project at hand, decide what type of business cases you want to cover with this software, see what's common, see what's different in those business cases, and prioritize those business cases, and based on that, develop the best features. Really hard to say how to customize the software without knowing what the software is.
Yeah, no problem with that. Yes, you actually have to think of the, I guess, planning it properly, right? And creating the perfect roadmap, just as you mentioned, the fact that you have to consider all of the business cases, and those will always be specific to specific business goals of this particular business, right? So thank you so much for the answer. Got one more. And it's about the approaches for ensuring cross-platform compatibility of software developed for proprietary IoT hardware. Are there any specific kind of approaches for this kind of cross-platform compatibility?
Again, not sure what is the cross-platform stands for, but if it's cross-platform in terms of like client platforms, then there are, again, a set of universal best practices how to build a cross-platform compatible software. If we are talking about compatibility with different models and types of the hardware.
Yeah, I guess it's more about this one.
Okay. So when we're building an integral ecosystem of proprietary software around proprietary hardware, we have this blessing of have the hardware team actually on board with us. So what we can do, we can talk to them, we can plan that perfect architecture, we can sit and brainstorm on what are the potential further developments in terms of the hardware to make it easier to build some kind of universal modules, universal interfaces, universal mechanisms for bigger standard features like monitoring, like reporting, like alert rising, to make sure that the hardware team with all the new models for the hardware will follow the same scheme that we agreed together. And basically with any new developments on any side, whether it's a new feature on the software side, or whether it is a new model and hardware capability on the embedded side, to bring this to the attention of the whole team. And if it's needed to basically update this common vision of mechanisms, of standard flows, of like standard interfaces. But yeah, anyway, if we're talking about even a bigger cross-platform compatibility, let's say I have a very old iPhone and I want to configure a Bluetooth NFC activated device at hand, and I want to be sure that it will be activated, it will be configured, it will answer to the commands that I send with these interfaces in a kind of standard manner. That's why we're actually developing the software solutions. So when you have a proprietary software solution around your proprietary hardware, you are taking care of those compatibility things. So you just make sure your software is compatible with all those, say, client platforms. And it's the task for the software development team to ensure that whatever device you have, whatever browser you use, everything will go as planned. Not sure if I answered this question.
No. It was a perfect answer, actually. Thank you so much. I'm sure there will be more questions to come, but unfortunately we're pressed for time. So I just wanted to thank you so much for the presentation. It was really insightful, as well as the Q&A session. And we will actually round up right now. But before we do that, I just wanted to let you know that if you guys listen to this live stream, or maybe you could be listening to it already in a recording, we will also send it to you. You feel free to reach out to us, specifically to Alexandra and specifically to Max, who was the first speaker, on our LinkedIn channels, I mean on our LinkedIn accounts, as well as feel free to reach out to us to our main LinkedIn page, or specifically to me on LinkedIn for any questions you have. Also, we have an email, hello@yalantis.com, which you can use to reach out to us and ask more questions about creating solutions for proprietary IoT hardware, building our complex architectures, upgrading the architectures specifically for IoT solutions or in general, because those could be different ones. Feel free to do that. Also, feel free to ask questions later on to our inbox, and feel free to visit our website. And for those of you who are actually already working on their solutions and are struggling with planning them, we have something like an extra value that we would like to give to you before we round up our recording and the live stream. You can hit this link that I'm sending here in chat, and you can also receive it to your email box for all of those who were registered. All of you guys will receive it. And if you have a question or would like to request a plan for the architecture assessment, or you're struggling with road mapping your IoT solution, say you are at an initial stage or you are almost at the end before pitching it to an investor or to a group of investors, would be glad to help you out with those to get a bit more detailed into it and suggest some of the improvements. Feel free to reach out to us via this link. We will also send it to you to your inbox, as I said before. And also feel free, as I said, to ask more questions, because we are eager to answer them. We know that it's hard to cover all of them in a single recording. Thank you so much for listening to these presentations and for coming to our webinar. It was a pleasure to have you guys here and hope you enjoyed it. Have a great time.